So today we are going to see how we can solve an ordinary differential equation using our Python. We are not going to look at any complicated equations like non-linear equation or multiple variable equations. We are not going to look any of them. We are just going to look at a single dependent and a single independent variable equation, which can be of either order 1 or 2. We are also not going to look at more than one to second order. Okay. അപ്പോൾ നിങ്ങൾക്ക് ഈ എന്താണ് ഫസ്റ്റ് ഓർഡർ എന്താണ് സെക്കൻഡ് ഓർഡർ എന്നുള്ളത് അറിയാമെന്ന് വിചാരിക്കുന്നു. ജസ്റ്റ് ടു റീക്യാപ്പ്, ഐ എം നോട്ട് ഗോയിങ് ടു give you the mathematical solutions കാരണം അത് നിങ്ങൾ ഓൾറെഡി either in second semester or third semester, I don't know which class, you had differential equations എന്ന് പറഞ്ഞിട്ട് സെപ്പറേറ്റ് ഒരു mathematical subject തന്നെ ഉണ്ടായിരുന്നു. So I'm not going to explain how to solve it, but we are going to see how you can solve it using Python. Okay, so solution for mathematical part I'm not going to give. Okay, so you have two orders of differential equation. We are only considering two orders. The first order differential equation, the first order first degree basically. So it will be of the form, let's say dy by dx plus something is equal to 0. I assume that this is homogeneous. Okay, so this something can be a function of x, or it can be a function of a variable. So here I am saying that it is a function of y. Because when you differentiate, there are two variables. The one for which differentiation is done is called as a dependent variable. And the one with which you are differentiating is called as an independent variable. Now, why is called as a dependent variable? What is the reason that y is a dependent variable? The reason is like this. See, you can express y in terms of x. For example, y can be like x cubed plus x squared. So the y depends on the variable x. So it is called as a dependent variable. While x by itself doesn't depend on y, or x by itself stands alone. So it is called as an independent variable. Okay. So you are differentiating with respect to, you are differentiating a dependent variable with respect to an independent variable. And the extra term here will be a function of the dependent variable. Okay, so I'm not saying that always you will get something like this. I'm saying that there can be a dependency. Okay, so now using your normal way of mathematical solution of differential equation, it is something called as variable separable form. Where you separate, let's say this is dy by dx plus x equal to 0. So this I can write as, oh sorry, this should be y, because it should be a variable of y, plus y is equal to 0, which I can write as dy by dx is equal to minus y, or I can write dy by y is equal to minus x. You just cross multiply, you integrate both the sides. 1 by y is ln of, or log of y with the base e, that is equal to minus x squared by 2, something like this. And then you can write y is equal to minus, sorry, e raised to minus x squared by 2 plus some constant. This is your normal mathematical solution. Okay, I just gave it to you so that you will understand the program better. Okay, so in Python, you are going to use the package SciPy. And in SciPy, or I would say in SciPy, the module integrate, there is a function called as ODE int. Okay, so this is the function. ODE means ordinary differential equation integration. Okay, so this is the one, when you give the arguments, it will give you the solution. What are the arguments? The first argument is a function, or the function of the ordinary differential equation. Second argument is the initial condition, so that you can find all your constants. Third argument is the variable, for in this case, or you say this is the independent variable. Variable with values to be evaluated. And you can additionally give extra arguments, which we are not going to discuss. Okay. So first of all, you need to create this function of ordinary differential equation. Now, how will you create that function? So you define a normal function. Let's say my function name is ODE fun, something like this. Okay. And you pass arguments. Now, what are the arguments to be passed? The first argument to be passed here, or to be declared here, is your dependent variable. And the second argument to be passed here is your independent variable. The first argument is dependent variable. So in this example, the dependent variable is y. So you pass y. And the independent variable is x. Okay. So you define the function something like this. Def ODE fun in bracket. First, the dependent variable y, and second, the independent variable x. Okay, fine. Now you define the function. So what should be the function that you should define? You should define the function in such a way that the left hand side is your dy by dx, and the right hand side is the rest of the terms. So if you look at this, dy by dx plus y is equal to 0. If you look at this thing, okay, then this is equal to minus y. So this is your left hand side, and this is your right hand side. So the left hand side should have only a first order differentiation, and rest should be in your right hand side. Okay, so whatever be terms, for example, it can be added with some constant, something like 10. So that should be in the right hand side. Okay, fine. So once you make your equation in this form, then you should return from this function the right hand side of the equation. That is, I can write def ODE fun of your independent variable. So your dy by dx is equal to minus y, and you return dy by dx. So dy dx. So this is actually a variable. This is not actually your dy by dx. I'm just naming it as a variable. Okay. So basically, you are returning the right hand side, which is this. Okay. So, and to make it as a solution, we'll see the complete program, but let me just give you a brief on how to do this. ODE int, you call the function ODE function, comma. Next is your independent variable x. Sorry. Next is your initial condition x0. So you might declare x0 is equal to 1, something like that, before calling this function. And the next one is your independent variable x. Now, once this function gives you a result, it will be stored in, let's say, z. Okay. So if you do integration of this, or you solve this function, basically you should get some value of z, and whatever value you get, that will be in terms of x squared by 2. So this is your solution, right? So the x value you specify here will be substituted in that solution. We'll see that again. So x, you need to generate points. So you say numpy dot linspace of 0, 20, 10 or 11. Okay, which generates x is equal to 0, 1, 2 up to 20. So what this does, the ODE int does is, there are two steps which you cannot see obviously. First one, it will make z is equal to e raised to minus s square by 2 plus c. 2, it will substitute x0, which is the initial condition, and find c. And the third one is it will substitute x0, sorry, x, which is this one, and get the vector z. So finally you get z is something like z is equal to, let's say, 0 0.1, 0 0.3, 0 0.5 up to some last number. Okay, this is the first order differential equation. Okay, so let me just show you a sample code so that you will understand. Okay, so I hope you have understood how to solve the equation, and I hope you have also understood how you can use the ODE int function. So what should be the arguments of the ODE int function which will help you to solve in Python? Okay, is there any questions regarding this? You can ask. Okay, no questions means either you understood everything or didn't understand anything, whichever way. Okay, unless you ask, I don't know whether you have understood. Okay, fine. So let me just show you a sample code. Okay, I hope you can see my screen, right? So let's start. So let me just skip this. Let's go and look into this first. So what I want to look into is ODE int. Okay, here my equation I have already given is dx by dt plus x equal to 0. Okay, so x is the dependent variable, t is the independent variable. Fine. So so I set my initial condition x0, some variable x0 is equal to 1. Okay, and then finally I want to call this function ODE int. I should pass the function. I should set an initial value, which I already did, and I also should pass t. Right now, t is linspace of 0, 20, which means it will generate points from 0 to 20 with a separation of 1. So it will generate points. This will generate points um, 0, 1, 2, up to 20. Okay. So you got this t value. You got this x0 value. Now what is the model? So model is a function name which I give, and it accepts two inputs. First is the dependent variable. So in this case, it is dx by dt. So x is my dependent variable. And the second is the independent variable, which is t. Okay. So if I want to return something, then I should return the RHS of the equation, in which the LHS is only dx by dt. Okay. So I return minus x. So dx dt I guess minus x, and I return dx by dt. So when this OD int called model, it will get this minus x as the output. Okay, and then it will be stored in x. So now x has the solution, in which the values of t is substituted. So solution is almost like e raised to minus t square by 2, in which I substitute the values of t from this, which is done inside this OD int function. And then I plot this. Okay, so this is a simple ordinary differential equation. Let me just run this and show it to you. Okay, let me just share my full screen. So I have run this, and you can see it is an exponentially decaying function, because e raised to minus t square by 2 is an exponentially decaying function. So it is that how you plot. Okay, so I hope you have understood this. The only catch here is you want to define this model function correctly, in which your whatever is returning from this function is the right hand side of the differential equation, where the left hand side is only the first order differentiation dx by dt, and all other terms will come in the right hand side. So even if the 0 here has some other form like e raised to minus x or something like that, it will come here. So for example, if my equation is something like this, e raised to minus x. Okay, so in that case, my left hand side is dx by dt, but my right hand side will change as minus x plus e raised to minus x. Okay. So here I just need to add e raised to exponential of minus x. I think it can be imported from math package. And if I run this, let's see if it shows an error. Okay. So that is your output, right? Okay. So this is regarding first order differential equation. Now, how will we do the second order differential equation? Okay. So that needs a bit of a manipulation that we will see now. So just give me a minute. I'll just connect my other screen to you. Okay, I hope you can see my screen. So what is second order differential equation? First degree second order. So this is second order ordinary differential equation. So in second order differential equation, you will have a second order differentiation plus you can have a first order differentiation. It is you can or you cannot have, and then you can have a constant or a variable. So let's say this is 2y is equal to, if this part, the next part on the RHS is 0, then it is a homogeneous equation. If it is non-zero, it is a non-homogeneous equation. Okay, so let's consider a non-homogeneous equation, or let's consider non-homogeneous itself. Okay, so let's say this is some e raised to minus x, something like this. Okay, so I can write this as y double dash plus y dash plus 2y is equal to e raised to minus x, where y double dash means d square y by dx square, y dash means dy by dx plus, and plus 2y is equal to minus e raised to x. Now, whenever you are going to solve in Python, you can solve only first order ODE using ODE. ODE into വെച്ചിട്ട് നിങ്ങൾക്ക് ഫസ്റ്റ് ഓർഡർ ഡിഫറൻഷ്യൽ ഇക്വേഷൻസ് മാത്രമേ സോൾവ് ചെയ്യാൻ പറ്റത്തുള്ളൂ. You cannot solve a second order differential equation. So what we are going to do is to convert second order ODE to first order ODE. Okay, basically now you will get two equations, but both are of first order, and then you can just substitute in ODE int and you will get the value. So how are we going to do this? Let's do this by substituting some values or some variables. Okay, you might need to do it using pen and paper, all these things. Okay, so that it will initially you might need to do, like when you're once you are used with Python ODE int, you might not use pen and paper. Fine, but initially you should always use pen and paper. Now let's say I let y is equal to x2, or let me start with x1, and I let y dash is equal to x2. Okay, now I write y double dash is equal to, I can bring all these terms to this side, because finally we need the maximum order in the left side and all other terms in the right side. So I can write this as minus y dash minus 2y plus e raised to minus x. Okay, fine. So y dash, y double dash, I can write it as x2 dash, right? Y dash is x2 implies y double dash is equal to x2 dash, which is dx2 by dx, right? This is equal to minus y dash is basically my minus x2, which is from here. And minus 2y is basically 2 into x1, which is basically from here, plus e raised to minus x. Now here x is a independent variable, so whether it is x is there or not, it doesn't matter. We are concerned only about x2 and x1. So this is one equation. And in this equation, we are dealing with x2 dash. So the left hand side has of order 1 and all other terms are on the right hand side. Fine. Similarly, from this equation, if I do a differentiation in that equation, I have x1 dash is equal to x2. Why? Because x1 dash is equal to y dash. We have already told that y dash is equal to x2, which means this is equal to x2. This is equation number 2. So now you have broken your second order differential equations into two first order differential equations. X2 is equal to y dash, but we are not bothered about that. Finally, what is there in the equation? Does it have two different differentiations? It doesn't have. If you look at the equations that we have currently written, there is only one differentiation, or there is one order, and the second equation also has one order. And all others are expressed in terms of x2 and x1, and x is fine because that is our independent variable, so it doesn't matter. Fine. Now you solve, you give these two equations to the ODE int to get the solution. Okay, so let's write that function again. So you defined ODE function 2 for second order. Let's say you pass the variables here x comma t, or in our case here it is y comma t. Okay, now remember, when you have a second order differential equation, you will have two initial conditions. Implies there will be two initial conditions, because there will be a condition for y at t equal to 0, that is y of 0, and there will be a condition for y dash at t is equal to 0. Implies you will have a condition for x1 and there is a condition for x2. So please don't forget that. Okay, so once you define the function here, we will define the function now, and after that you will be giving the initial condition, let's say y0, as a, this is the condition for y of 0, and this is the condition for y dash of 0. And then you generate x using linspace, it's a 0, 20, and you call ODE int with the function ODE func2 with the initial condition y0 with the independent variable x already generated here. And this will be a vector of 2 columns. Okay, it will be a vector of 2 columns, The first column is the solution of y. Second column is the solution of y dash. We'll see that. Fine. So when you call this ODE func2, it will pass y as a list. So y will have, because you have given the initial conditions as 2. There are 2 initial conditions, means there are 2 different differentiations. So one is a normal, one without a differentiation, and one there's a differentiation of order 1. So your x1, which is y, is the value of y at 0. And your x2, which is y dash, is the value of y at 1. Okay, I hope you understood. Now your dx1, which is this, is equal to x2, and your dx2 is equal to, which is this, is equal to minus x2 minus 2 into x1 plus e raised to, or exponential of, minus x. And you return both x1 and x2. Return as a vector. The first term is x1 dash, and the second term is, sorry, the first term is x1 dash, and the second term is x2 dash. And this will give you the solution. ആർക്കെങ്കിലും മനസ്സിലാവാത്തതുണ്ടോ? ആർക്കെങ്കിലും, you can ask doubts now, because I know it is a bit confusing, but if you have any doubt, you can ask me. ഇത്രേ ഉള്ളൂ കാര്യം. ഇത് ഈ ഒരു കൺസെപ്റ്റ് മനസ്സിലാക്കി കഴിഞ്ഞാൽ you can solve any order, 2 or 3 or 4 or 5 or any order you can solve. But you should understand this concept. Is there anybody who hasn't understood this? Okay, വൈവ ചോദിക്കുമ്പം don't say to me that okay sir ആ സമയത്ത് മനസ്സിലായില്ല എന്ന് പറയരുത്. Now is the time. Okay, I'll explain once again. Second order ordinary differential equation. A sample is this one, where you have of second derivative, you write it as y double dash plus y dash plus 2y is equal to e raised to minus x. But for your convenience I have written. So ODE into വെച്ചിട്ട് നമുക്ക് first order ordinary differential equation solve ചെയ്യാൻ പറ്റുള്ളൂ. So what we do, we convert the second order into 2 first order ordinary differential equations. എങ്ങനെ convert ചെയ്യും? You say that the first dependent variable is some variable x1, and the derivative of the dependent variable is another variable x2. Okay, so x1 dash is equal to x2, and x2 dash is equal to y double dash. So എല്ലാ ഇക്വേഷനും ചെയ്യുന്നത് പോലെ ലെഫ്റ്റ് ഹാൻഡ് സൈഡിൽ ഒരു ടേമേ പാടുള്ളൂ, right hand side should have all other terms. So you bring these terms to the right hand side. So that is what we have did here. You bring all the terms to the right hand side. Okay, so but we know y double dash is x2 dash. കാരണം ഇവിടെ ലെഫ്റ്റ് ഹാൻഡ് സൈഡിൽ it should be only one term which is actually a first order differentiation. First order differentiation left hand side പാടും. Okay, so y double dash is x2 dash, it's the left hand side. Y dash എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ we know it is x2. Y എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ we know it is x1, and plus e raised to minus x. Similarly, I can write x1 dash is equal to x2. Okay. So if I solve for x1 dash and if I substitute it here, I'll get x2 dash. And if I solve for x2 dash, I'll get the corresponding value of x2. Okay. Fine. Now, നമ്മുടെ കോഡിനകത്ത്, since there are two differentiations, we'll have two initial condition, one at y equal to 0 and one at y dash equal to 0. So നിങ്ങൾ ഈ code before doing the function, when you start the code, make sure you have defined two initial condition. The first one is for y0 and second one is for y dash of 0. Then you generate the value for x in which your final output should be substituted. We call ODEINT with the function initial condition and the independent variable. So when you call ODEINT, ODEINT ODE function y, t എന്ന് പറയുന്ന value automatically ഈ ODEINT pass ചെയ്തോളും. We are not worried about that. Okay. പക്ഷെ നമ്മൾ ODEINT വിളിച്ചപ്പം we give y0 as a variable of or a list of two elements, which means ODEINT knows that you are actually going to do a second order differentiation. Okay. And then you do x1. So x1 is actually so y is actually a list. Two values ഉണ്ടാവും. The first value is your x1 and the second value is your x2, where x1 is actually y and x2 is y dash. So my dx1 is x2 and my dx2 is this. Okay, and you return dx1, dx2 in that order. So it will give the result in y by substituting the values of x, and if you put a plot, it will plot the graph. Okay, I hope you have understood. Fine. Okay, somebody told that there was some problem in their home because of rain. That is fine. So I'll upload the recorded video. Okay, so let's see the code. Okay, I hope you can see my code. So you see that ഇതില് ഞാൻ ഡിഫറൻഷിയേറ്റ് ചെയ്യുന്നത് ഇതാണ്. ഓക്കെ, സോ ഞാൻ എഴുതിക്കുന്ന കോഡിന്റെ കമന്റ്സ് നന്നായിട്ട് വായിച്ചു നോക്കുക. ഐ തിങ്ക് ഐ ഹാവ് എക്സ്പ്ലെയിൻ ഇറ്റ് പ്രോപ്പർലി ഇൻ ദ കമന്റ്സ്. സോ ഡി സ്ക്വയർ എക്സ് ബൈ ഡി ടി സ്ക്വയർ, ടി ആണ് ഇവിടെ ഇൻഡിപെൻഡന്റ്, എക്സ് ഡിപെൻഡന്റും ആണ്. So I can write this as x double dash plus x dash plus mx is equal to raised to minus t. So x double dash is equal to dx by dt. Okay, so the initial condition you gave 2, you generate t, and then you say x equal to ODEINT. You call the function, give the initial condition, give the value. Okay, അപ്പോൾ ഇതില് x1 x2 ഞാൻ അങ്ങോട്ടും ഇങ്ങോട്ടും മാറ്റിയാണ് കൊടുത്തേക്കുന്നത്. ഇതിനകത്ത് ഞാൻ എക്സ്പ്ലെയിൻ ചെയ്തതിന്റെ x1 അല്ല അല്ലാതെ കൊടുത്തേക്കുന്നത്. Let me change that, otherwise you will get confused. I hope I have given it in the opposite order. Let me see. So x1 is equal to, and okay, so x will be passed. So 0th value of x, I'll edit the comments also. So let's say, so we need to convert second order differential equation to first order one. So x double dash plus x dash plus 10x is equal to raised to minus t implies x double dash is equal to minus x minus 10x plus e raised to minus t. So let x2 is equal to x dash and x1 is equal to x. So I can say x2 dash is equal to minus x2 minus 10x1 e raised to minus t. So there are two first order equations. First is x1 dash is equal to x2, sorry, and second is x2 dash is equal to x2 minus 10x1 plus e raised to minus 2. The value to be returned from this function is the coefficient of x1 and x1 dash in the form x1 comma x1 dash. So this should be x2 and this is x2 minus x1 plus e raised to minus 2. So in the function, the first value is y of 0. Y എന്ന് പറയുന്നതാണ് first. Second എന്ന് പറയുന്നതിനാൽ that is y dash. So first is x1, second is x2. So I can write this as, let me write dx1 is equal to x2 and dx2 is equal to minus x2 minus 2 into x1, sorry, not 2, 10 into x1 plus m dot exponential of minus t. Okay, so this is dx1 and this is dx2, and you see that it will return x, and x will be actually, if you print this x, we comment out the plotting part because anyway you can plot it. Now if you print this x, you can see that it is of two values. Okay, so let me just run this and I will share the screen where it generates the values. Okay, so I hope you can see my screen. Okay, so in this one you see that there are two columns generated. ആദ്യത്തെ column എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ when you apply differential equation solve ചെയ്ത് കഴിയുമ്പോൾ you will get some equation like e raised to minus t square or something like that, yes, minus x square, അങ്ങനെ എന്തോ കിട്ടും. Okay, ഇനി അതില് when you substitute the value of x, നമ്മൾ ലിൻ സ്പേസ് വെച്ചിട്ട് നമ്മൾ x ന് വേണ്ടിയിട്ട് ഓരോ വാല്യൂ നമ്മൾ ജനറേറ്റ് ചെയ്തിട്ടുണ്ടായിരുന്നു, അത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ you get all these values. Okay, now അത് ഡിഫറൻഷിയേറ്റ് ചെയ്ത് when you substitute for x you will get the second column. The first column is the normal val and the second column is the one in which when you differentiate the output and substitute the value. Okay, so I hope you have understood that. It's very simple. നമ്മൾ ഈ ഒരു ഫംഗ്ഷൻ എങ്ങനെ എഴുതണം എന്ന് അറിഞ്ഞു കഴിഞ്ഞാൽ that is the most simplest one because it doesn't take too much of an effort. Does anybody have any questions? ആർക്കെങ്കിലും എന്തെങ്കിലും ചോദിക്കാനുണ്ടെങ്കിൽ ചോദിക്കാം. ഇല്ല? Okay, good. Then I need to ask you something. നിങ്ങൾക്ക് നെറ്റ്വർക്ക് തിയറിയിൽ ട്രാൻസിയൻസ് തുടങ്ങിയോ? RC transient, RL transient, etc. കാരണം I'm going to put a question on transients. So if you haven't started, you should let me know now. Otherwise, I will put the experiment. So നമ്മുടെ എക്സ്പീരിയൻസ് ഏതൊക്കെയാണ്? I have just shared it with you. Okay, So initially solve differential equations like this. Then there is a current transmission through an RC network that is driven by 5-volt DC. The signal is 5. So random condition when you're applying a constant voltage and then you are applying a voltage at t equal to 0. അതുപോലെ second order differential equation case you have an RLC circuit. So I am asking you whether you have been taught the transients in an RC or RLC circuit. അങ്ങനെ പഠിപ്പിച്ചിട്ടുണ്ടോ എന്നറിയണം. Anybody? കാരണം I saw that ബിജു സാർ അതിനകത്ത് നിങ്ങളുടെ ഗ്രൂപ്പിനകത്ത് RL transientsന്റെ ഒരു വീഡിയോ ഇട്ടത് ഞാൻ കണ്ടു. So I just want to know whether it is taught. Yes, yes. Okay. So I hope then you know how to generate the differential equation from the RC circuit and RLC circuit. Okay. So your experience will be this that I will post anyway. And you can try this because experience ഒക്കെ simple ആണ്. RL circuit RC circuitലും രണ്ട് condition വെച്ചിട്ട് it is very easy. Okay, so you can do it. And like I will try to post 4 of them. രണ്ടെണ്ണം നിങ്ങൾക്ക് differential equation തന്നിട്ട് solution കാണാനും ബാക്കി രണ്ടെണ്ണം ഈ ഒരു ട്രാൻസിയന്റ് പ്രോബ്ലംസും ആയിരിക്കും. Okay, so I'll post the experiment maybe today or tomorrow morning. Okay, now if you have any general comments, anything to ask, like you want to know anything, now is the time you can ask. I think ഒന്നുമില്ല. ഞാൻ ഇതുവരെ പറഞ്ഞത് മനസ്സിലായോ? That is my question. Okay, so at least some are replying. That is good. Okay, at least some have understood. Fine. So നിങ്ങൾക്ക് എന്ത് ഡൗട്ട് ഉണ്ടെങ്കിലും you should ask. എക്സ്പെരിമെന്റ് ചെയ്യുന്നതിൽ if you have anything before at least before the deadline എന്നാണ് submit. So ഇത് assignment in the next Friday ആണ് deadline. So make sure you study this, make use of the lecture and understand the assignment. And so before Friday you can ask regarding any doubt. We are here to clarify that. And next Wednesday we will have Viva. 4 experiment Viva ഉണ്ടാവും. 4, 5, 6 sorry 4, 5, 6, 7. No, this Friday. Okay, sorry. This today I'll post the experiment and your deadline will be on Tuesday for this experiment. So either you can do it very fast. So Wednesday you will have Viva for 4 experiments, 4, 5, 6, 7. And there's a deadline tomorrow for your 4th and 5th experiment. Okay, so if somebody wants to resubmit it again, you can submit. And 5th experiment, I think very less number of people has done till now. So they can submit it by Saturday. And in our experiment Viva, there will be on Wednesday. Next week in English are class on Tuesday and Friday. Okay, fine. Okay, so I think then we'll stop the class and